Hello, AP Statistics class. I hope you're all doing well and welcome back to class. Today we're going to be talking about chi-square test for independence. So we did homogeneity. Hopefully your assignment went well, and if you got homogeneity, independence is pretty close. The do part and the plan part are identical. It's just how you set up your hypothesis is different. So we're going to be using chi-square test for independence if we want to determine whether there's convincing evidence of association between whatever two variables are on your two-way table. So that association word is what makes it different than homogeneity. So what we're going to do, we should have already all done that, page 9, there's a scenario that we are going to use on page 11, so I would take the time to pause and read this scenario. When we get there, we are not going to do these two questions. If you look over them and you have a question about them, it is just review topics, kind of how we did when we did this review, setting up the bar charts. So if you look at that and you want me to make a video, I will be more than happy to, but I want to focus these videos on the actual chi-square test for independence. So we are going to go to page 10. And it says the chi-square test for independence is used to test association. So association and independence, they're probably going to use the word association more than independence, honestly, on an AP question. And it's just asking, are these two things related? Is there a relationship between one variable and the other variable? So no association between two variables means that knowing the value of one does not help us predict the value of the other, which that should sound familiar. I've said that sentence before. Does knowing one thing help you know the probability of another thing? And that was when we were talking about independence. Are two things independent? If knowing one doesn't help you predict the other, then they are independent. So if there's no association, I don't know what I was about to write, no association, that is the same thing as saying they're independent. So you can use either wording when you're setting up your stuff. So if you're doing a chi-square test for independence, if it's asking about association, your null is always no, right? Null is no. Just like if we go back and look at the patterns, there's no difference in the distribution. That there was no difference in the specified distribution. We didn't use the word no in there, but it's the same concept. They're all that there's no difference, it's the same, or there's no association between the two categorical variables in the population, and that HA would be there is an association between the two variables. And then you write your alpha. So our plan, the official name would be chi-square for independence. But again, there's a broader term for this. Any chi-square test that's using a two-way table, you can call it chi-squared two-way test, which is the same thing we wrote for homogeneity, because these are very closely related. So you could write either of those. Some people pick this, that way it's both for right, but I don't know, it's just, you should understand that there is a difference, because if you don't understand the difference between homogeneity versus independence, then I'm not sure how you're setting up your null and alternative right for each problem. But if you want to play it safe on your AP tests, you can just write chi-square two-way test for both of these type of tests, because you go to the same place in the calculator. So for your conditions, we always start with random, so it has to be, this is again the same type of wording that is messed up. So it's supposed to be, I don't know why it says designed right there, but we'll just leave it. Comes from a random sample. You could cross off well designed if you want, or a random experiment, randomized experiment. Which it might not say the word experiment, it might say what? Treatment. So I want you to notice that it's not two samples, it's a sample, and I'm probably going to say that a lot throughout this video and the next video. But so we don't have to talk about, if we look here, how it's two independent random samples. That should be an S. Sorry, that's on page 6. It's just one sample, so there doesn't need to be independent. So don't talk about independence there. Don't write independence, because it's an important fact that when you're doing this test, it's one sample. And then if it's a random sample, you still need to check 10% rule. That your sample size is less than 1/10 of the whole population size, and our large counts condition hasn't changed, that all expected counts are greater than 5, and you still need to show that, and you need to write them down. So if you notice this do should look similar, it's the same, right? Because even in the calculator, you're going to go to the same. So the numbers don't change based on homogeneity and independence. It's the wording of your hypothesis, which then affects your conclusion, that's going to change. So your expected count is still the same formula. Row total times column total divided by table total. Your chi-square statistic, that's the same for all of these chi-square tests, even goodness of fit. And then your distribution's the same, skew to right, you shade, you write your degrees of freedom, and that shaded is your p-value. And then you make your conclusion same as always. So I don't really know what I was thinking with all this space for keystrokes, because it's actually the exact same as the keystrokes for homogeneity. So we're just going to say same as homogeneity, which I feel like I misspelled that. I always feel like I misspell that, so you can laugh at me at home if I did. So same as homogeneity, which means you're going to, you got to first put it in matrix. First put table in matrix, which I'm not going to write out how to do that again. You can just go back to that page. And then you're still going to go to two-way test, which again, I'm not going to write where that is because you can just go look. And what that means is, again, if you need your expected count, after you do this, you can still pull up that expected matrix and component matrix if it asks you about the components. Okay, so let's do a problem. I don't know what that is. So this is that scenario that I said you should read on page 9. So go back and read that so you know what it's talking about. It's talking about how people they test them to see if they have low, moderate, or high anger, and then if they experience heart disease or no heart disease. And it says, does the data provide convincing evidence of an association, it's like your key word that you're doing independence test, between anger level and heart disease. So it was one sample, and they divided up their sample based on anger level and heart disease or no heart disease. And we're trying to see, is there association in we're trying to decide, is there association period between them using our sample. So we're going to start with state. HO is no. There you go. That's a good way to remember it. There is no association between, and this is where you should just be using your sentence or your question, anger level and heart disease in the population of interest. Always remember to never, now I was talking and I misspelled interest. Isn't it nice to know some things never change? What I was going to say is always remember to never address a sample in your hypothesis. We are hypothesizing about a population. And your HA is the same thing, but there is an association. In the population of interest. Okay. And again, I did the exact same thing. Okay. So then we're going to write down what our alpha is set at, 0.05, because they didn't say. So now we're ready to plan. So write down our method. So you can pick one or the other. I'm going to be specific. It's chi-squared for independence, because they use the word association, which is also chi-squared two-way test. It's kind of the more broad name. So your first condition is random. What was random? Now you need to go back to that original problem. And they took a random sample. And if you want to go ahead and write down what the amount was, it was of 8,474. Was it specific on the type? Let me see. People with normal blood pressure. Okay. Let's see how I'm doing. Yeah, I'm crooked. So then that means we need to check 10% rule. Notice how it was a random sample, one sample. And so we need to assume at least multiply by 10 people in the population, which is just people with normal blood pressure. So we're pretty confident there's at least 84,740 people with normal blood pressure. So assume at least, what am I writing? 84,740 people. You could just say in population. I'll be specific with normal blood pressure. For population, I'll say. Okay, so then we need to do large counts. So we need to make sure all our expected count is greater than 5. So we could go do it by hand if you prefer. And right, we have six set of variables, right? So we would need to do row total, column total, times table total for each 6 different, I don't know the word I'm looking for, observed values. There you go. Or we could go ahead and go kind of jump start our do and do it in the calculator. So you could do it by hand if you want and then check it or whatever you feel like doing. Now I didn't type it in ahead of time, I should have, but why not just do it together? So first we got to do a matrix. So we're going to go to menu. Oh, no. First you want to type the name of your matrix. So I just do A. And then I want this sign to store it, so I push the control button and then the number, control, and then the button next to 9. And now I need my matrix. So menu 7, 1, 1. I have how many rows? 2. Push tab, 3 columns. Remember, you don't include the totals. If you always do that, like I just did, push tab after you type it. And push OK. And now type it in. Oops. This is why I do things ahead of time. So there's your matrix. Did I do it right? Yes. And now we're going to do our test. So menu, stats test, two-way test, 8, pick your observed matrix, go to OK. And now that's for your do, but remember we're trying to get our expected matrix, so you push VAR, and you do stat.expect for the expected values. Push enter, And there's your expected. So let's write these down next to, we'll write it on the right hand side for each one. Put an E or something to show that those are your expected. So the first one was 69.73. I'm going to go down 30,040.27. Next one is 106.08. 4,624.92. 14.19 and 618.81. So if we notice, the smallest is what, 14? So they're all greater than 5. I'm going to come down here and say, oh wait, smallest expected count was 14.19, so all are greater than 5. So we can use our chi-square distribution. That's what it's testing. So now ready for do. So we already did it, so it should go pretty fast. Go back to your calculator. If you ever go home, which I'm on there, but just to show y'all, if you ever accidentally go back home and you don't want to redo it, go to current, page 4, or option 4, and it'll take you back to your original page you were on. That's why it's good to use documents. So your chi-square value is 16.076. Our degrees of freedom, which is 2, which that should make sense because remember you do rho minus 1, which would be, it's 2, you have 2 not including total, so minus 1 would be 1, and then 3 minus 1 is 2, 2 times 1 is 2. I don't want y'all to forget about these formulas just because we're doing the calculator. And your p-value is 3, I was about to say that doesn't make sense because it's higher than 1, but it's because it's so small, to the -4. So move your decimal over 4 times, so it would be 0.003. 228. Oh. So what does that mean when you draw your distribution, your chi-square distribution? It's a really small area, even smaller than what I just did. That's your chi-square test statistic, and that area is 0.003. Okay, so we're ready to conclude. Should be pros at this by now. So go ahead and try to conclude on your own. You can pause the video and then just jump ahead and see if you wrote the same thing, or however you want to do it. Or if you just want to listen to me write, that doesn't make sense, but you know what I mean. Since the p-value 0.0003 is less than alpha equaling 0.05, we reject HO and do have convincing evidence that, and now we just write our HA. We got convincing evidence that there is an association between anger level and heart disease in the population of interest, which is people with normal blood pressure. You don't have to write that part, but so you can go back and see that we actually answered our question. So that is how you set up a chi-square test for independence. The next video we're going to kind of focus on how do you know which one to do out of all these different chi-square tests.